We're going to be talking today about the Solana Thesis. I couldn't help but throw the pun up on the title here. So Solana is a decentralized layer 1 blockchain in one global state with low fees, high capacity, and fast finality. We'll get into all of this today. I don't actually have that many slides because primarily we're just going to be talking through how things work and what this vision for the network is. There's a ton of information on Solana.com. I think a lot of that's actually been translated into Korean as well. So there's a lot of good resources out there to talk about this stuff. But, to start out, Solana is trying to do something a little bit different. The one global state machine really is the vision for what this network is designed to be. And one global state machine, this, if you think about it, this is the original vision that Ethereum started on, right? Was we're going to have all of the information for the world's computer in one global state. And there's differences. Obviously, the network has diverged since then, and Solana was founded much later. But there's a lot of original DNA that goes back to the credit of the Ethereum community for actually bringing us forward into the world of smart contracts and helping establish these underlying principles of how this works. So what is one global state machine? When we talk about one global state machine, the idea here is that any application on a network can compose with any other application on a network because they have a shared understanding of their state, which is the universe of where applications run. This is really core to what the goal of the Solana project is, which is to scale that state machine as large as possible to synchronize the world's information as close to the speed of light as possible in a decentralized and permissionless way. And this is a sort of a key component, which is since day one, block building has been permissionless. Anyone can run a validator. The minimum stake is one Sol. This is a different approach than a lot of other folks are taking towards scale, and in part because Solana simplifies the stack. Right? In a lot of architectures, you have multiple layers between the consensus layer, some sort of DA layer, an execution layer on top of that. By simplifying that into one thing, which is called C-level on the Solana virtual machine, you change the dynamics of what it means to be building on a network in this way. So we'll go through a few of the technologies here, but these are really the core concepts behind it. One of the really differences in how Solana works relative to other networks is this concept of program reusability. So a very simple example here is if you are using Uniswap, you are talking to that program and you are going through and hitting liquidity pools in that program when you're doing trading. If you are deploying an NFT in the EVM space, you are first deploying the NFT contract, and then you are deploying the data for which you're going to create that NFT out of. And that's actually a much heavier deployment architecture than you see on Solana. So on Solana, if you are minting an NFT, you are simply sending data to an on-chain program, which is sort of, you can think of it as a ZK circuit if you want to think about that, but it's not a zero knowledge, but it is a program on-chain that will always do the same thing when you feed it data, the same way a DeFi application is. This is a really big component for scale, for keeping the state smaller and allowing transactions to be much, much cheaper on the network. So, in one example for here, you can mint an NFT for fractions of a penny on Solana. That data is all on-chain. The difference is it doesn't have its own management contract specific to it. It is using a contract that has been immutably deployed on the network to create this. And this concept of program reusability extends to a whole different range of applications, whether it is a multi-sig like squads, where components of that are reused on-chain and components of that are custom deployed when someone's using something like that. This integrated architecture is another thing that we've been talking about a little bit on the panel. But what this means is, again, everything's in the same global state. But the base layer actually is not particularly opinionated. The base layer of Solana can actually run a whole different series of different types of applications built in different languages that all run on the Solana virtual machine. And one of the components that really goes into making this possible is that the whole thing runs on BPF or eBPF, which is a Berkeley packet filter sort of LLVM model where the code that's distributed is in a native format on the network. Now you can write applications for Solana and we call them programs as opposed to smart contracts because every network needs its own terminology for some reason. But programs on Solana, you can write them in you can write them in C, you can write them in Rust, you can use Python, you can use Anchor, you can even write them in BPF natively. All of this is really designed for optionality, and it means that new languages can be added over time. There's a project going on right now to actually add Move language support to Solana without actually having to add the entire Move VM. And this is what we were talking about a bit on the panel, about how the idea of what is modular and what is not modular is really, it depends where you're looking at the stack, right? An approach to bringing multiple VMs to a blockchain could be just that. You're going to support multiple different VMs. They're all going to operate in different execution environments. They're all going to settle back to the same place. That is the sort of the L2-centric or roll-up-centric view of the world today. Another option is you just make the base layer very unopinionated, so you can write programs however you'd like to actually write those programs. Even if projects like Neon EVM, which is an EVM implemented via smart contract on Solana, and Neon EVM has been benchmarked to about 700 transactions per second when it's running on top of Solana. Now, those are fairly simple EVM transactions, but you can actually get pretty decent performance out of an entire VM, entire emulation layer of Ethereum running on top of the EVM architecture running on top of Solana. And this is really only possible with an integrated architecture approach here. What's really cool about this is you can actually do atomic transactions from code that is written in EVM with Solana programs. So you can actually take a fork of Uniswap or a fork of Balancer, and you can have a transaction that touches that and then also hits up Jupiter for the Solana DeFi markets as well. This idea of atomic composability, requires everything to be in one state today. There are visions of the future that involve fraud proofs or sort of other types of modules to be able to do this, and state proofs. But today, if you want atomic composability, which is really the type of composability we should all care about, this is the kind of composability where you can't get rugged in the middle of the transaction. That stuff requires one global state today. And you have this between L2 or on specific L2s, but not when you're talking between them. The other piece here is the performance flywheel. So the founding team for Solana, many of them actually came from the mobile phone world. They came from Qualcomm before and deeply integrated circuitry work on basically very slow systems, right? The early smartphones and especially flip phones were very slow systems. So there's architectural changes in how we approach this stuff that is baked into that sort of core DNA. One small example of this is before transaction executes on Solana, it actually has to specify all of the accounts and all the state that it wants to talk to, as well as the instruction set. Why is this necessary? To allow for parallelization within one global state. So in other approaches like EVM, there's a global write lock taken. Transactions execute one after another, and they cannot execute in parallel because a transaction in other languages and other platforms can actually spiral out into sort of an indeterminate series of places. This is why transaction simulation is difficult on some networks, whereas transaction simulation on Solana, you always know what the instruction set will do because you know all the accounts it needs to touch. If the transaction starts executing and needs to touch an account that it hasn't actually specified, the transaction by definition must fail in the network because it's not actually able to do everything that it said it was going to. This also means that you can run things like transaction schedulers that will allow for differentiated fee markets between different pieces of state on the network. So this is a concept called local fee markets. We'll get into that a little bit later too. But that parallelization, the ability to do multiple things at the same time because you know what everything is supposed to do, that is really core to the Solana thesis. And the performance flywheel is directly downstream of that. So as hardware gets faster, the Solana network is also able to get faster. This is just based on Moore's law, and as you can throw more compute through machines, either because they have more cores or because each core gets faster, you can increase the number of what we call sort of compute units, which is approximately 10 nanoseconds of time. The compute relative to 10 nanoseconds of time is about how a compute unit is calculated. That number can increase over time because the actual hardware running the network has increased in performance. Additionally, Solana, is a very bandwidth and gossip-heavy protocol, and we can get into some of the architectural decisions on why that is. But bandwidth connectivity is also increasing, not quite as fast as Moore's law, but it's going up quite fast as well. And so even places that, 3 years ago you could not run a Solana validator because you could not afford to get symmetric 1 gigabit internet connections, you now can, especially in the developing world. It's less of a problem here in Korea. when it comes to internet connectivity. But these are all sorts of things that enable the network to get faster and basically piggyback on the hardware innovation that, Intel and ARM and all these other companies and Qualcomm are doing every year. And that's kind of one of the main flywheel components. There's also software innovations that come from optimizing systems, but the goal is every time you're able to push new performance, you should be able to reduce the fees for using the network. And this is the idea that the cost to send a transaction on Solana should be about the cost of hardware doing a signature verification. Signature verification is a pretty simple activity, so we want to keep pushing that base compute fee, that base fee for a Solana transaction, as low as possible. Now, you might have seen this sort of Solana fees are actually going up, right? Solana is actually the second highest revenue generating protocol, which was sort of not expected. Ethereum is still by far the highest, but Solana actually generated about $17.5 million of fees one day last week, compared to Bitcoin, which is about $2.5 million in fees per day. Ethereum is, well above that. But this is sort of based on these concepts of priority fees, which is that when you have a parallel blockchain, you're able to access multiple pieces of state at the same time and have those operations run concurrently. If I'm trying to mint an NFT and everyone else in this room is trying to mint the NFT, that by definition has to be a serial operation, right? There's no solution in computer science to this. This is just classic database problems of you can't have two people write to the same spot at the same time. One of their values has to go first. So how do we solve that, right? One of the ways to solve that is to build fee market competition for that specific piece of state. So if there's a really hot NFT mint, the cost there may skyrocket for those fees. Additionally, if there's something like an arbitrage event where there's a potential large profit availability from something like a liquidation, that is something where you may also see fees spike. But unlike you see in other networks, that fee spike is limited to that piece of state where there's competition. If someone else is trying to, pay for something at a convenience store using USDC, or I'm trying to send, tokens to someone else, or I'm trying to do a DeFi trade, that won't actually be impacted in terms of the fee because it's in a separate part of the network. These are kind of core concepts to how this stuff is built. Another one of these core concepts is optionality. And optionality, I will say, is different than the modular vision of what optionality is. Optionality means that developers have a lot of different tools and characteristics to achieve the same thing through several different means. So one of these is we talked about priority fees, but there's also this idea of stake-weighted quality of service, which is another way that you can increase the likelihood that transactions will land when there's, high competition to write for a certain piece of state. But this also means things like the token extensions framework. The token extensions framework was just launched earlier this year. This is a new token program for the network, which is designed to actually bring permissions to the token level. So this is designed for token issuers to be able to say, I only want my token to be traded by users that I have KYC'd, right? Now, we can talk about how undegen that is as a philosophy, but this is really core to the vision of the network where the base layer, the base core of Solana needs to be as unopinionated and neutral as possible. But the stuff built on top of it can be as opinionated and private as someone wants it to be. This is just how the internet works, right? You can go to every website, but you can't log into every website. This is, that core concept there of you don't have to register to be on the internet. You just have to register for certain types of applications and websites. So token extensions are a component designed to make it so you really never have to launch a private blockchain or a private layer 2 again, and you can do all of that on the mainnet architecture. So yeah, going into some of the technologies here. Parallel execution, we've talked about a little bit. I want to kind of go back to this because this is one of the key components of Solana that makes it different from other networks, is the ability to execute multiple transactions at the same time if they are not overlapping. This core comes from the Qualcomm history of most of the founding team, because this is how you had to build processors back in the old days when you need to be able to do multiple things at the same time. Specifying the state beforehand is key to that process. So priority fees and stake-weighted QoS, these are tools for sort of improving optionality again on the network. But this is different than a global fee market. I know I just talked about this piece, but I want to kind of go back to this because a global fee market is really good if you have a limited supply of transactions, right? If transactions are scarce and incredibly valuable, a global fee market is a great way to control that option. Solana is sort of building for a different future, where transactions are incredibly abundant and incredibly cheap, but there may be very high competition for transactions in certain places, like certain DeFi events, like NFT mints. You can see these areas where there's really high demand for competition. So next generation standards and tooling is sort of another, concept that we sort of try and bring as the foundation. So the Solana Foundation, right, we're a Swiss nonprofit, as like most blockchain foundations are, but our goal is to do as little as necessary, which is sort of a strange thing to say. It's sort of the best type of job security you can have if your job is to do as little as you need to do. But what this really means is that our structure is really around supporting the ecosystem development as opposed to leading ecosystem development. But there are times when, something like the token extension standard gets built up from Solana. But a great example of this is Metaplex. So Metaplex is the NFT minting protocol on Solana. And this was built in 2021 at a time when a lot of people were taking the ERC 721, which was an incredible standard and still remains that today, and just sort of copy pasting that onto their vision for what NFTs would look like on their network. NFTs on Solana are built very different. They're built in user space. They're not defined by a protocol level specification. It's 3 accounts, and those accounts have a certain amount of metadata interpreted in a certain way to produce that type of outcome. But what you can do with Solana NFTs ends up being very different. There's royalty enforcement mechanisms for it. There's compression systems so you can bring the cost of minting an NFT down to fractions of a penny. And this is done because the model of what an NFT is was totally rethought based on the performance characteristics and the differences in the Solana network compared to other networks as well. This also leads right into something called state compression. State compression is a way of taking a lot of data that is stored sort of on-chain, not entirely on-chain, but the hashes are stored on-chain, and building it into a Merkle tree. And so we can do concurrent updating of leafs in a Merkle tree. And this is really how you're able to get state compression that enables, again, 100 million NFTs for about $1,000 of transaction fees in order to make that happen. And that is actually getting better soon with some of the upgrades that are coming to generalize that state compression as well. But this is, to go back to sort of the performance flywheel, this is finding areas where there's real demand from people building on the network, doubling down on those technologies, and trying to improve what the capabilities are on top of that. Token extensions are another one of those like framework technologies. There's 16 different token extensions. They include things like transfer hooks, which is if you're similar to how hooks work on Uniswap, it's sort of like that, but it's in between a transaction. So if I'm trying to transfer tokens to someone, a transfer hook can be called in the middle, and the token issuer sets this up, which can say, I'm going to allow or deny this transfer. I'm going to look at your wallet and determine, based on any sort of on-chain criteria, is this transaction able to go forwards? Now, there's a few ways to look at this. One is this is exactly what banks want, to be able to make compliant stablecoins that'll comply with sanctions law. The other way to look at this is a great tool for degens that want to do crazy degen things with tokens, right? This programmability into the token program that's more than we've seen from other networks is really designed to enable new types of applications to be built. One of these, for example, is a transfer hook that automatically burns 5% of the tokens transferred. Right? This is just a very cool deflationary mechanism for meme coins, which we'll be talking about on a panel later. But that also then can be used by a fund to say, every time a token is transferred from my tokenized real estate fund, I want to take half a BIP and I want to put it into a fund. This can also be used by game developers to actually create sustainable sources of revenue for games, as opposed to having to just print more Ponzi tokens, which is, the death spiral that a lot of games have unfortunately gotten into because they're not able to create long-term sustainable economics. And so a lot of these tools, again, we're trying to get them built at the most unopinionated base layer possible, because we actually don't know anything more than the developers building on the Solana ecosystem. We just happen to be the ones who have a grant budget at the foundation. But having too much opinion on how something should be done, as opposed to actually listening to what folks in the community and developers are building, is, I think, one of the challenges that a lot of ecosystems have faced. We were talking in the last panel about narratives, right? the narratives for Solana are not coming from the foundation. They're not coming from Raj and Anatoly, the co-founders. They're really coming from what people are building and what the opportunities for that technology are, and then the work that can be done to support that. The exception for that is FireDancer. So FireDancer is a really big project to build a net new validator client for the Solana blockchain. This is something Ethereum has done an incredible job of. There's 6 different validator clients. You can mix and match from consensus to execution. I think there's more than 6, but there's 6 sort of independent code bases there. That's really great for a bunch of things. One is just safety and diversity of validator clients. Another is resiliency of the network. So Solana is the first network after Ethereum to have a second independent validator client built out for it. So the primary client, which is called Agave, which is built by a group called Anza, that is built in Rust. And that is the primary client that many people use today. There's a MEV-boosted version of that called Jito, which is similar to Flashbots. But the FireDancer project is built in C. It's an entirely different dependency tree. It's built by a bunch of high-frequency trading engineers to build the most performant client that they can for the Solana network. And the goal of that project is a 100x increase in performance and capacity of the Solana network. Now, it'll take a few years for that to actually hit those sort of targets, but Q4 is the target for releasing of the FireDancer client for mainnet. It's currently built out on testnet. And so we see this as another major step forwards in changing what's possible to build using the Solana technology and even on blockchain, right? This is sort of the key flywheel thesis here that I keep going back to is when you transition and make things a step function cheaper or a step function more performant, it unlocks entirely new cases that wouldn't be possible otherwise. Think back to the days of DSL and dial-up internet, and the idea of a video pre-roll ad would have just blown the minds of people back then. The idea that you were going to waste so much bandwidth on a video ad would have been crazy, right? And now we just annoyingly click through those things. But that was only made possible because the base layers of the Web 1 or Web 0 infrastructure at that point got so much faster that the additional capacity was there. This is also the flywheel that Amazon.com has done, that TSMC has done, with reinvesting, everything that they're able to in pushing technology forwards. And so this is kind of one of the core concepts for Solana is fees, economics, they're all in some ways coming later, right? This is sort of what we were talking about before in the panel, which is that product market fit is one of the hardest things to find in blockchain. And so if you just keep pushing on ideas that might work, it's very hard to figure out what actually is going to, create value, not in a monetary sense, but actually for the world. If you focus on making blockchains cheaper and more affordable to use with more performance and higher throughput and higher capacity, that is a thesis where then the smartest people in the world can come and build whatever they want to build on top of it. This is the same vision that Ethereum has sort of held to over the 10 years or plus of the project that has really made it so powerful. And so, we owe, as a whole industry, a huge debt of gratitude to the Ethereum community and the Ethereum developers. But this is really a different take on what the future of this technology could look like. So token extensions, we talked about these a little bit. We're sort of running a little bit low on time. I thought I had another slide there. There we go. So one of the things with token extensions is they're really designed so you can build permissioned systems on a permissionless network. This is something that hasn't really been done yet. In the ability to say, we're going to take all these different components, there's 16 different token extensions in one composable token program that's universally supported by wallets, applications, explorers, etc. You can now build something like an on-chain money market account that has interest-bearing tokens where the interest value accrues daily, that you have to do KYC in order to be able to trade, and that if you lose your seed phrase, the token issuer can actually reach into your wallet, take those tokens, and move them into a new wallet. Now, for the degens in the room, that's scary, and I understand it, and token extensions probably are not something you're excited about. But if we really want to get to a world where regulated finance is starting to build on blockchain, I would love if government regulations were lessened. I would love if we lived in a more, libertarian economic system where we're actually able to do the things that we all believe, that the reason we all own Bitcoin as well as any other tokens we own. But the world is not changing in that direction in a time scale that matches with a lot of our product ambitions. And so this is sort of a world where you can do something on mainnet, which is better than doing them on side chains. It's better than doing them on private blockchains. And over time, we can start to change the world's culture of traditional finance and move them towards this permissionless, decentralized world that we're all building for. Thanks.